Hey folks, good morning or good afternoon depending on when you're watching this. Um, in this lecture I'll tell you a little bit about functions and their graphs and how we can plot them. Um, so here you'll see some of the goals that I set out for this lesson, for this video. So let's get into it. We'll work through several examples. So to begin, let's consider this function e to the power of minus quantity x squared plus y squared. And I'd like to know the answer to these 4 questions. We'll work through them together, but maybe now's a good time to pause the video and you can think about them on your own. All right, welcome back. So let's think about this. The domain of e to the minus quantity x squared plus y squared, well, there are no domain issues here. There's no problem plugging anything into the exponent, any real number. So really any x and y values in combination would work here. That is to say, if our inputs live in R2 in the xy plane, the domain is that whole plane. And now the range, well, here there's a little more nuance. We have to think about this. E to the minus power of a real number. Well, when that real number gets large, e to a very negative value doesn't become negative. If you think carefully, remember it gets close to 0. It will never actually get to 0. Remember that e to a minus power is 1 over e to that power. So it gets small, it approaches 0, but it doesn't get there. So we might say, we'll use parentheses, an open interval. But on the right side, well, what happens if x and y are small? Or in other words, what's the largest this function could be? Well, the exponent can never be positive. X squared and y squared are positive numbers, and we're taking the negative of that. So the largest that the exponent could ever be is 0. And e to the 0, of course, is 1. So the highest value that this function can achieve is 1. So all values of the function live between 0 and 1, including 1, but not including 0. So part C, where is it large and small? We sort of did this as we thought about the range, but, well, when the exponent is small, when it's close to 0, or a small negative number, the output of the function will be higher, relatively higher, close to 1. And then when x or y get large, it will sort of damp down the function, and it will get close to 0. And in fact, this happens very quickly, which we'll see on the graph. So we might say something like f is close to 1 when x or y are close to 0. And f is close to 0 when x or y is large. And to think about the graph, well, we'll use Sage to do the work for us. So we'll take a break here to switch over to Sage. All right, so here's my CoCalc Sage worksheet. Remember that to evaluate a cell, we hit Shift-Enter. So here we go in the very first cell. And there's no output. We just told CoCalc that we're going to call this function f of x. And now we hit the next one, and here's where we'll see some action. And here is our plot. We see, as expected, in the center where x is 0 and y is 0, the function is tall. In fact, it achieves z equals 1, an output of 1. And then as x and y move away from the origin on the plane, the value gets smaller. Now, there's no way to zoom in or zoom out as you did on your graphing calculator, but what we can do is change the bounds of the function, the bounds of the graph. So maybe we'll change this to go from -2 to 2 in both the x and the y directions. And here you see what I mentioned before, how yes, it gets to 1 in the center, but the output, the z value, gets very close to 0 pretty quickly. And if we went further out, you'd see that it's almost identically 0 everywhere, except for that little bump in the middle, close to x equals 0 and y equals 0. Now, I'll give you the definition of a graph. We know this. We talked about it last week in terms of two variables. One input and one output. But if we've got two inputs, right here is the definition of the graph of a function. It's all the points in 3 space of the form x, y, and f of xy. That is, in other words, the z value is equal to the output of the f of the function f, xy. So let's take a moment to examine the graphs of these two functions. F of xy is x squared plus y squared, and f of xy is x squared minus y squared. And we'll take a look at Sage for some help with these. So for the function x squared plus y squared, I put them both on the same line. So now when I evaluate this, it will assign the name of the function and graph it for us. And we see this nice bowl shape. This is called a paraboloid, not a parabola, that's in 2 dimensions, but a paraboloid. And maybe we can convince ourselves this is what we should expect to see. As x or y gets large, the output of this function gets large, and it should never be negative, because x squared or y squared can never be negative numbers. And x squared minus y squared. So why does this look like this? Well, in the x direction, let's see, where's the x direction? We'll line this up. Here's where x is minus 1 and x is 1. So now this is the positive x direction. As x gets further from 0 in either direction, the positive direction or the negative direction, since there's a positive coefficient here, the output of the function gets large. But in the y direction, as either y gets small or large away from 0, the minus y squared contributes negative values here. And so we get this saddle or Pringles shape. We might call this a hyperboloid.